We are taking chapter 11 conic sections of class 11. So we have already discussed about circle and parabola. Now we will be discussing the ellipse. Now one thing you need to understand before we go ahead, that the ellipse and hyperbola, they share a lot of similarity. So whatever we are discussing in ellipse will be somewhat applicable to hyperbolas also. So please understand these things very carefully. So let us start with the ellipse. What exactly is ellipse? Ellipse is all those points, say this P1, P2, P3. So these are the points whose distance from two fixed points, say one is F1, one is F2. We call them focus, and because they are two, we will call them foci. So these 2 points, foci, they are from any point. If you add these distances, they will always be a constant. We'll see about what that constant will be. So the distance, see, I take any point, say P4 here. So P4 F2 plus P4 F1 will be equal to P1 F1 plus Pn F2 and likewise. So let us formalize the ellipse, because you see Earth is also an ellipse. So whosoever is going to be in geography in his life, so he'll understand that the Earth will be modeled as a ellipsoid. So you'll understand and you will know about the semi-major axis and semi-minor axis. You will be hearing it called quite often. So what exactly that is? This is the major axis. What is the major axis? The line which is passing through these two focus, F1 and F2, this is called the major axis. What about the minor axis? The minor axis which is perpendicular to this line and which is passing through the center. So this will be your minor axis. Major axis, minor axis. What are these points? The F1 and F2, they are having distance C and C. So these are C. The major axis, this partition is A, this partition is A. So in all, the major axis will be 2A. Similarly, the minor axis will be 2B, that is semi-minor axis will be just B. So this whole will be 2B. Now, we need to formalize certain things. What will be the formalization? We'll see that what exactly that constant is. When I add QF1 plus QF2, that there has to be some constant. So let us take, we know that this is C, this is C. So this distance is C, this distance is C. And by the definition of ellipse, any point on P on this ellipse will have a constant distance if we add the distance of this point from F1 and F2. So from F1 to P, what will be the distance? This is C, this is C, but will not take this C, because this to this distance we know that this is A. So from F1 to P, the distance will be C plus A, exactly like this. If I add F1P, I can write it like F1O plus OP, F1O plus OP. This is my C, this is my A, so C plus A, right? This one is C plus A. How about F2P means this distance. This whole is A, this is C. So what will be this distance? C minus A minus C. So I'll write A minus CA. And if it gets cancelled out, so it will be 2A. So the constant distance we are talking about in an ellipse is nothing but 2A. How about this 2? Q is also a point on ellipse. So QF1 plus QF2 will be equal to 2A, as we just found out. What is this distance? If this is C, this is B, this will be what? Under root B square plus C square by Pythagoras theorem, and similarly this one. So let us add these two and equate it to 2A. So we are adding under root B square plus C square plus under root B square plus C square, that is 2 under root B square plus C square. We are equating it to 2A. When we equate it to 2A, we are actually getting the relationship between A, B, C. Semi-major axis, semi-minor axis and C. So this is the, if we just square both sides, C will be equal to under root A square minus B square. So this is going to be heavily used in hyperbola also. Now there are certain special cases of an ellipse. If we take this expression again and this particular expression, and if we place say C equal to 0, so what will be the result? A equal to B. A equal to B means what? A is equal to B. A is equal to B means, this means that this is a circle. So ellipse will become circle if A is equal to B, means this is also equal to R, this is equal to R, and we know that if the locus of point which is equidistant from a center point, all those points, they will form a circle. Next is C equal to A. If we place C equal to A and B equal to this B equal to 0, what will be the answer? The answer will be C equal to A. So this will be straight line. There will be no ellipse. There will be only straight line. How about eccentricity? Eccentricity is nothing but the ratio. Ratio of what? The distance of the center from foci to the ratio of center from the vertices. So center to foci is C, center to vertices is A. So E is equal to C by A. Eccentricity is nothing but E is equal to C by A. Most often we will be using it in this form. C is equal to AE. This form we are going to use it. Now the standard equation of ellipse, what it is going to give you, the standard equation of ellipse is like this. X square by A square plus Y square by B square equal to 1. We are taking it as 0, 0 origin. This is C0, this is minus C0. This is any point XY. So the equation will be x square by A square plus Y square by B square equal to 1. If the main axis or the axis in which this focus lie is x-axis, how about the focus now lie on the y-axis? The equation is going to become x square by b square. See, here x square has a denominator a square, but here the denominator is b square. So if the major axis is on the y-axis, then this will be x square by b square plus y square by a square equal to 1. So the equation will change. And now the question arises that how actually we found out this equation? How this equation has come? So this is quite simple. This is what the definition is going to play the role. This is any point pxy. Any point you take pxy. We know that the distance from this point to this point, if we add, we'll get to a. We have already found out that. So the distance from this point to this point, take the distance formula. You have to find xy with minus c0 and again xy with c0. So this is the distance formula. Just add them and equate it to 2a. Just rearrange it and you will see that the equation is going to be x square by a square plus y square by a square minus c square equal to 1. But we have already found out that c square is a square minus b square. You can directly put b square here. So this is the equation of the ellipse. So any point on the ellipse is going to satisfy this equation. This is the final equation. Now you want to go converse. Means I have this equation. Now let us see whether this equation is correct or not. So we know that Pf1 is this. Just put this value, means y square is equal to b square 1 minus x square by a square. This is actual equation. We have just found out from this only. This is the actual equation. Now I am putting it here and I just found out that the value b square is equal to a square minus c square. I can place it here. And when I solve it, it will be a plus c by ax for Pf1. Let us take Pf2. Similarly, Pf2 is going to be a minus c by ax. Let us add this. This is going to be cancelled and it will be 2a. So converse is also true. Converse is also true. Now let us discuss something which may be of importance in later questions. Let us write the equation in this form. See, something is getting deducted from 1 and you know these two are squares, so there cannot be negative. So this will always be less than 1. This will always be less than 1. So x is going to lie between minus a and a. X is going to lie between minus a and a. But the ellipse, if it is on the y-axis, y is going to be between minus b and b in this case. So these are the standard equations on x-axis and y-axis. Now let us discuss about the observation we have found out. Ellipse, as we have seen, it is symmetric with respect to both the coordinate axes. May it be xy, minus xy, x minus y and minus x minus y. And the foci, they always lie on the major axis. The foci always lie on the major axis. So the major axis, how we are going to determine? This is determined by finding the intercept of the axis of symmetry. That means that the major axis is along x-axis. If the coefficient of x square, this one, has the larger denominator, if this denominator may be a square, may be b square, if this is larger, then the major axis is x-axis. If the denominator of y square is greater, then the axis is y-axis. This you have to understand. Now coming to latest rectum. What is latest rectum? Latest rectum of an ellipse is actually a line segment which passes through the focus and whose endpoints are on the ellipse. Which passes through the focus and whose endpoints are on the ellipse. So if you have an equation like this and you say this is my latest rectum and I want to find out the length. So what is this length? See, this is C. So you know C is AE. So this is nothing but AE. So this is AE. This is AE and this Y I don't know. Let it be L. Let it be L. Now let us put this value into the equation of ellipse because they are going to satisfy. I am talking about this point. If I can find xy here, I will be able to find the length because this already I know. This is c, which is equal to ae. So let us place it here, and we know that with the e and c square is equal to a square minus b square, we can just find out this. So ultimately L we can find out from this equation. This will become b square by a. And now actually we have found out the y, but this is only half. This is total. So one is b square by a. Just make it twice. 2b square by a. So this is the length of the latest rectum. Now let us take some questions. Find the coordinate of foci, the vertices and the length of major axis, the minor axis and the eccentricity, and the latest rectum of the ellipse. This is your ellipse. See, you have to just see that which is the greater denominator. 25, so the axis is going to be x-axis. This is very true, right? So the major axis is going to be x-axis because this is larger. 25 is larger than 9. Let us equate this equation with x by a plus y square by b to 1. A square is 25, b square is 9. So a and b you got 5 and 3. What will be c? C will be equal to under root a square minus b square. Just place it here, you get c equal to 4. Now you can easily find out the foci. Foci is nothing but plus c and minus c. Vertices are, you just take a, minus a 0 and a 0. The major axis is going to be how much? Major axis is going to be 2a. Minor axis is going to be 2b. So this will be equal to 10, this will be equal to 6. And eccentricity will be given by, you know that c equal to ae, e, you can just find out c by a, that is 4 by 5. How about the latest rectum? That will be 2b square by a. Place the value, it will be 18 by 5. Now find the coordinates of the foci, the vertices you have to find out, the length of major and minor axis. The eccentricity also you have to find out. The ellipse is given like this. Now we have to find out, or we have to change this in the scenario or in the form in which we can easily find out the a and b. So let us divide both sides by 36. We will get x square by 4 plus y square by 9 equal to 1. Now here we see that the denominator of y is greater than 4. So this is giving us a sign that the major axis is on the y-axis. Major axis is on the y-axis. So you have to equate this equation with x square by b square plus y square by a square equal to 1. So b square is 4, a square is equal to 9. So b is 2, a is 3. The rest you can easily find out because c, you are aware that it is equal to under root a square minus b square, which is going to give you under root 5. E is c by a, so you will get e as root 5 by 3. The foci are 0 root 5 because you know that this is c, 0 root 5 and 0 minus root 5. Vertices are 0 a and 0 minus a. Length of the major axis make it 2a, length of the minor axis make it 2b, then 2, actually this will be 2b, this is 2a. And the eccentricity will be root 5 by 3. Find the equation of the ellipse whose vertices are this and foci are this. So as you see that the x has value, y has no value. So you will equate it directly with the x square by a square plus y square by b square equal to 1. And just see that a is given 13, c is given plus minus 5. Place it in this equation, you will get b. And now you have got the a and b. Place it in this equation. This is your equation of the ellipse. Find the equation of the ellipse whose length of the major axis is 20 and the foci are 0 plus minus 5. Here you see that 0 means x-axis has no value but y-axis has. So it is, you will equate it with x square by b square plus y square by a square equal to 1. You are going to equate it with this. Now a is the semi-major axis. This is the major axis. So basically major axis is, this is 2a. So a can be found out by 20 by 2, that is 10. C square is equal to a square minus b square, you can find out b. So b square and a square you have found out, just place it in this equation. This equation will get this as the equation of the ellipse. Now find the equation of the ellipse with major axis along the x-axis and passing through this and this. So when it is passing through x-axis, major axis, so the equation is going to be x square by a square plus y square by b square equal to 1. Since these 2 points actually lie on this ellipse, you just have to satisfy it. So place 4 and 3 one time, place minus 4 and 4 second time. These 2 are equations and you have to solve it. You can easily get a square and b square, place it here and just make it more formal to see. So this is what your answer would be. So this is one more part of the we have taken ellipse in the conic sections. We'll be taking hyperbola in the next section. Thank you so much.